lesson, we're going to be learning how to find the vertex of a quadratic relation. If you're given the quadratic relation in factored form, you want to start by finding the x-intercepts. The x-intercepts here are positive 3 and positive 5. With those, let's make a little rough sketch of our parabola over here. Since a parabola is symmetrical, it's going to look something like that. Since parabolas are symmetrical, we know the axis of symmetry is going to be right directly in between the two x-intercepts, which would make it x equals 4. Now that we know where the axis of symmetry is, you can kind of guess as to what the coordinates of the vertex is. It's going to be 4 and some unknown. We can find the y-coordinate of the vertex by taking our axis of symmetry value of 4 and placing it directly into factored form. Once you do that, you can simplify the numbers in the brackets. 4 minus 3 is just positive 1, and 4 minus 5 is negative 1. Afterwards, you want to multiply these numbers. 1 times negative 1 is negative 1. That means we know the x-coordinate of the vertex is positive 4 and the y-coordinate of the vertex is negative 1. Therefore, the vertex is positive 4 and negative 1. If you're given the vertex form of a quadratic relation, you can just look at the equation. The vertex would be positive 4 and negative 1, which matches what we found earlier from factored form. However, if you're given the standard form of a quadratic relation, that's a little bit more tricky. Over here on the top left, you'll see the general form of standard form. A represents the coefficient of x squared, B represents the coefficient of x, and C represents the constant. In this particular situation, the A value would be positive 1, the B value would be negative 8, and the C value would be positive 15. Once you have the A, B, and C values, you can use this formula that finds the axis of symmetry. I'm going to substitute in the B value to the numerator, so that would be negative 8. And in the denominator, I'm going to substitute in the A value, which is positive 1. On the top, we actually have negative 1 times negative 8, which makes positive 8. And in the bottom, we have 2 times 1, which is just positive 2. And 8 over 2 simplifies to just 4. Now that you have your value of x, you can substitute it back into standard form to find your value of y. So we're going to take our value of 4 and substitute it here and here. We're going to be using the order of operations, which is BEDMAS. We're going to do this first. So 4 to the power of 2 is the same thing as 4 times 4, which is 16. Everything else stays exactly the same. Next, we're going to multiply these two numbers. So negative 8 times 4 gives you negative 32. That 16 stays the same at the front. Now we can simplify this as 16 minus 32 plus 15, and that gives us negative 1. Therefore, the vertex is positive 4 and negative 1, which matches the vertex we found from vertex form and factored form.